In this video, you'll see how to work with equations with two variables. So an equation with two variables would be something like this: 10 equals x plus y. Up until this point, we've had just one variable in the equation, but now we've got two different variables in the equation. And I just want to know, what are some possible solutions to this equation, 10 equals x plus y? And I want to express my answer as an ordered pair. So what do I mean by that? Well, think to myself, if x is equal to 1, so my x coordinate is 1, then y would have to be 9 because 1 plus 9 is 10. If x is equal to 5, then y would have to be 5 because 5 plus 5 is 10. And if x was equal to negative 3, well then y would have to be 13 because negative 3 plus 13 is 10. Now I want to know if these given ordered pairs are solutions to the equation. So I have the two variable equation, y equals x minus 8, and here's my x coordinate 8. I'm going to substitute that for the x there. So is y, which is 0, equal to 8 minus 8? Yes, because 8 minus 8 is 0, so that's a true statement. Now is my x coordinate negative 4, that's my x coordinate, minus 8. I want to substitute my y coordinate for y, so I've got negative 10 here. So is negative 4 minus 8 equal to negative 10? No, it's not, because negative 4 minus 8 is negative 12, so this would be no. Next, here's my x coordinate 0, and my y coordinate is going to be negative 8. So is 0 minus 8 equal negative 8? Yes, it is. And again, I just want to substitute my x coordinate for x, my y coordinate for y. So my x coordinate is 5. Subtract 8. Is that equal to my y coordinate, negative 3? Yes, it is. So how many ordered pairs do you think are possible solutions to this equation, y equals x minus 8? There are in fact an infinite number of ordered pairs that could be solutions to this equation. So let's take a look at that same equation, y equals x minus 8. Here are the three ordered pairs that we found as solutions. So I'm just going to plot these on my coordinate plane here. So 8, 0 is right here. And then 0, negative 8 down here. And finally 5, negative 3 right here. Let's take a look at these points here. You see how they all line up on this diagonal line? Right? That is an interesting thing that happens when we have one equation with two variables. Right? And the way that this equation is written, we actually end up getting a straight line. Remember when we said that there are infinite solutions to these equations here? One equation with two variables? Well, this line that we just filled in here by connecting the dots represents all the possible solutions to this equation. So what do I mean by that? It means if I take a point on this line, so I'm going to take this point, 10, 2. Oh, sorry, that's a positive 2. This is a solution to this equation, y equals x minus 8. If I substitute the 10 for the x and the 2 for y, I get a true statement. And that'll be true for every single point that we make with this graph. So if I have a linear equation, an equation with two variables here, and I want to graph it, I'm going to make a table of values to help me show those ordered pairs. And I'm going to choose at least 4 values for x, and I always choose 0 as one of those because 0 is an easy number to work with these. And then I'm going to graph those ordered pairs and connect the points to form a line. And I want to put the arrowheads at the end of that point, those lines, to show that there are an infinite amount of solutions. So let's go through an example. Here is my equation, y equals 3x plus 1. So what I want to do first is just make some headers here. This is going to be my x. Here, I just plug in my equation. This is what I get as my y. And then here, I just write in my ordered pair. So I'm going to choose maybe -2 for x. Always want to choose 0. I could choose 1, and let's choose 3. So now I just want to substitute all of these x values here. So my -2, and I'm going to multiply that. 3 times -2 plus 1. And I've still got my -2 here, or 0 here, sorry, x is 0 here. 3 times 0 plus 1. X is 1 here. So I've got 3 times 1 plus 1. And x is 3 in my last one. So I have 3 times 3 plus 1. And now I just want to solve all of these here. So 3 times -2 is -6. -6 plus 1, -5. So my ordered pair is -2, -5. 3 times 0 is 0. 0 plus 1 is 1. So my ordered pair is 0, 1. 3 times 1 is 3. Plus 1 is 4. So now I have 1, 4 as an ordered pair. And 3 times 3 is 9. Plus 1, 10. So I have 3, 10 as an ordered pair. The nice thing is if I did this right, I will get all my dots lining up in a straight line here. So let's plot them. -2, -5 is right here. And so let me label this -2, -5. 0, 1. Here's 0, here's 1 right there. 0, 1. 1, 4. 1, 4 up here. And finally 3, 10 all the way up here. And it looks like I can connect all of these with a straight line. So let's try that. Connect this point here all the way down through there. So I've got this straight line, and remember this straight line is representing all the solutions to the two-variable equation y equals 3x plus 1. And I could choose any point on that line and it should be a solution to the equation. So for instance, if I choose this point here, this point is 2, 7. If I substitute it in here, 3 times 2 plus 1, what do I get? I get the y-coordinate 7. Alright, let's practice some on your own here. So you want to name one ordered pair that would be a solution to the equation y equals 5x. And there are infinite solutions to these. One you could choose. You could say, well, if x was 3, y would have to be 15. I want to know, is 7, -2 a solution to y equals -2x plus 10? So I'm going to substitute. My y-coordinate is -2. My x-coordinate is 7. So I'm substituting those for the variables. And if -2 times 7 plus 10 is equal to -2, then 7 -2 will be a solution. So I get -14 plus 10. That's equal to -4. That's not equal to -2. So no, it's not a solution. Alright, and now let's try to graph this equation y equals x minus 9. Remember, we want to choose 4 values for x, so I'm going to choose -1 and 0 and 1 and 2. And I'm going to substitute -1 for my first value of x, and then 0, and then 1, and then 2. And so my equation is y equals x minus 9. So if x is -1, I just want to subtract 9. And -1 minus 9 is -10. So my ordered pair is going to be -1, -10. Next, 0 minus 9 is just -9. And so my ordered pair is going to be 0, -9. 1 minus 9 is -8. So my ordered pair is 1, negative 8. And finally, the last one, I substituted 2. 2 minus 9, negative 7. My ordered pair is 2, negative 7. So let's plot these points. Negative 1 here, negative 10 all the way down here, that's 1. And then 0, negative 9, here's another. 1, negative 8, here's another. And finally 2, negative 7 right here. Does this look like we could make a straight line going through all these points? Absolutely. Here's my line. And again, all of the points along this line should be solutions to our equation. And that's how we work with equations with two variables.